Good afternoon, everyone. I'm Whitney Stoll. I'm the DC Post first vice president, and I'm alongside Bree Beal, our program director, who is hosting this Teams webinar and will be monitoring the chat for us. Thank you all for joining us here today. We have over 100 registered participants from all over the country for this program, so I know you really can't wait to jump into the presentation with Dirk today. So it is my pleasure to welcome you all to the March First Friday Luncheon, and featuring Dirk Kestner from Walter P. Moore, who will be presenting the low carbon materials, achieving optimizing during design and construction. And we'll learn more about Dirk's work on sustainability through case studies and how sustainable structural and enclosure design can help with reducing embodied carbon in building systems shortly. But first, I'd like to introduce you to our First Friday series, which is provided to you through SAME's commitment to offering AEC community effective training, development, and networking programs. The DC Post is helping sustain the future of the profession with these monthly education-focused sessions to deliver topical and relevant content to our industry. So thank you all again for being here today as we start our program. But first, I'd like everyone to be able to go ahead and turn off your video and mute yourself if you haven't already. And please feel free to use the chat to introduce yourself to everyone, where you're calling in from, what post you're part of, and what you do. Share any your LinkedIn profile as well. So it's a great chance to network with everyone. And we will be using the chat throughout the presentation. So if there's any questions you'd like to ask, we'll make sure we can address them during the Q&A portion at the end. Also, this is a lunchtime session for those who are joining us on the East Coast, so feel free to eat your lunch during the program. So we're glad you can join us today, and we're happy we can offer this virtual program to our community, regardless of where you're attending from. So let's start with a moment of silence to remember our active duty military, first responders, and all who need our care and thoughts throughout the world right now. Great, thank you. If you all could please join us for the Pledge of Allegiance. So I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So thank you. And we'd like to take a moment to thank all of our DC Post sponsors for your continued support. We have AMT, Black & Veatch, Christopher Consultants, Consigli, Gannett Fleming, Spiniello, Stantec, WSP, Jacobs, Wood Peacock, AB Facilities Service Solutions, Archie Consultants, and Stanley Consultants. We truly appreciate your support. We cannot put on these events without you, and we are grateful for your outstanding sponsorship. And your support helps us meet our society goals, including providing excellent content to our members, industry and government engagement, building resilient communities, connecting with our leaders, future leaders through our student and young member groups, enriching the STEM pipeline, and preparing our military and veterans for life after service. So if you're not already a DC Post sponsor and would like to support the Post with annual sponsorship, we'd love to add your name to this list for future programs and events this year. So please visit our website if you'd like to learn more about sponsorship levels and how you can give back to the community. So, all right, enough talking to me. Let's we can definitely move on to our main program. And please note that this program will provide one professional development hour from the DC Post. So please look for an email with the subject line "Document Delivery" from us and Eventbrite with a copy of the program slides and your PDH certificate. We are recording this program, and we'll post a video on our website later on. So I'm not going to read to you all the learning objectives on this slide, since most of you probably saw this when you signed up and registered. Instead, I'm going to introduce to you our presenter. And while I do the introduction, and if you haven't done so already, please use the chat to introduce yourselves, share contact information, and where you're calling in from. And use the chat throughout the presentation to share comments, questions for our presenters. and we'll have time at the end of the presentation to ask questions, either from your chat, or we may ask you to turn on your video to ask questions directly to Dirk. But for now, please mute yourself and turn off your video during the presentation. So without further ado, Dirk Kestner is a principal and corporate director for sustainable design at Walter P. Moore, which is a 700-person structural and enclosure engineering firm. Dirk is a licensed professional and structural engineer and is a lead AP BD+C. Dirk is a current board member of the Carbon Leadership Forum, and he is the founding chairman of the Sustainability Committee for the Structural Engineering Institute, and served as an editor and coordinator of the committee's book, Sustainability Guidelines for the Structural Engineer. He was previously chair of the Lead Materials and Resources Technical Advisory Group and served as a subject matter expert during the revisions to the whole building life cycle assessment credit for the LEED version 4.1. He frequently speaks on the application of lower embodied carbon concrete mix designs and the use of the WBLCA to optimize design. He holds degrees from Cornell and the University of Texas at Austin, where his graduate research studied the use of recycled aggregates in concrete mixes. Dirk, thank you for joining us here today, and I'm going to turn the program over to you.
Well, thank you very much, Whitney. Let me get the screen share going, and I'll do a quick audio check. You can hear me? Everything's still working?
Yep, coming in loud and clear. It's all you.
Awesome. And now you can see the screen, right? Well,
yep,
thank you very much. Thank you for the opportunity to speak. Thanks for the intro, Whitney. I'm going to just kind of blow through a few quick slides about who I am and our firm, and then we'll get into the good discussion of, I put the quotes, low carbon materials, and the important part, I think we'll close with this in the title, but in the end, the important part of the title, we really need to make sure that we're making meaningful changes. So these changes need to be made both in design and followed through in construction. It makes no sense to kind of put something in design documents and then have it be unachievable. So as a firm, we are geographically diverse, working around the world. Most of our teammates are in North America, in the US, but we also have an India office as well as one in Panama. Our roots are in structural engineering, working on making buildings stand up, collaborating with contractors and architects for that. But we have grown over 90 plus years to have not only a structures practice and subdisciplines of structural engineering, but as well as an infrastructure and civil practice, a diagnostics and forensics practice, and then increasingly a technology practice that deals with how we work and how we use the increasing amount of data in our daily lives of getting buildings designed and built. The types of projects we work on range from sports projects. Those are probably the biggest, also the highest profile. I was lucky to start my career working on the one in the top left. But then, a lot of other different typologies as well, from cultural. I don't think we have any hospitals that I showed pictures here, as well as federal and then infrastructure type works. So here's a bit of our agenda today, as well as another picture of me. Just sometimes it's not on the slide when it goes out, but I'm going to work through first kind of embodied carbon basics. I put it under the title of embodied carbon as a performance metric, but making sure that everyone has some foundational knowledge and is up to speed so that I don't start diving into some things too quickly. And then hit a bit on how we are tackling embodied carbon during design and share a few case studies of different ways that we have made design decisions. And then that segues into procurement. And there's always an interesting handoff through design and procurement, because part of the design documents that we create are specifications. And depending on the delivery method and the owner, the freedom that a designer has in crafting specifications can vary. Sometimes they're prescriptive and kind of given to you. Other times you basically have to write them, but that transition gets to procurement and ultimately to the person who needs to to buy the materials and then get them in place. And all these links in the chain are very important to achieving success. Whitney mentioned a good bit actually about my background, but I'm trained as a civil and structural engineer, always with a focus in materials. For many years was a structural project manager, helping to get projects out the door and to oversee them while they were being built, with a passion for sustainable design and kind of an educational focus on materials. And during the past decade, as awareness of the impacts of materials has risen, it's been a great transition into this role where now I'm more focused exclusively on sustainable design. A couple of years ago, I was able to be part of the group that reviewed and then wrote the GSA Green Building Advisory Council advice letter on embodied energy, embodied carbon, and that was a really rewarding part to start to catalyze this discussion. So getting into that, embodied carbon basics and how we use it as a performance metric. The best part to kind of start with is understanding that fundamentally the two different places that we're looking at measuring carbon in the built environment. This is a great graphic from Skanska. Many times and historically, we've thought about operational efficiency, what we've got on the right side of the screen, the carbon emissions from the fuel sources, usually electricity and gas, and what's going on in that building or piece of infrastructure while you are operating it, what you see on the meter and the impacts of that. What was missed, and fortunately we're having a much more robust discussion about throughout our industry, and of course the topic of today, is the embodied carbon, or what happens before the asset is built, and how that's measured, and how we understand how the choices that are made influence that. So the embodied carbon is by and large emissions, and we're talking about carbon today, but it can really be any number of emissions and environmental impacts that occur, not on the building property, not during the life of the building, but what it takes to extract, harvest, make it, and get it built. So, and also we've historically seen, data and charts, and here I've got a donut plot that Architecture 2030 put together, showing where people have thought about global CO2 emissions, broken down by a few sectors. In transportation, the gray is one that we all understand really well. We get on planes, we get in cars, we have to fill them up, historically with gas, now more and more with electricity, but even if it's electricity, something's creating that power. So we've got emissions from that. And then the red is the operations. And then blue has been oftentimes lumped into industry, just a generic, lump. But once people started to really dig into this, they saw that a big chunk of that industry is industry related to what we do, the making building materials and construction. So what had been missed before, there's now an awareness of. And what that means is for buildings built today and in the future, instead of the historical thinking that, well, yes, there's embodied emissions, but they're small, and then we've got 50, 60, 70, maybe even 100 years of operations, what's happening if we're not paying attention to the embodied piece while the electrical grid or other fuel sources are decarbonizing and buildings are becoming more efficient, is that we get to the point where embodied and operational carbon are about 50-50, give or take. Depends on a lot, depends on where you are and how efficient your building is. But it's not something that can just be kind of thought of as an afterthought. And we also know from the many different studies and from the IPCC, I showed this here, that addressing CO2 emissions, it matters, if you can make a change early up front, what we can do in the next 10 years has more of a payback than doing it kind of incrementally over 50 or 60 years. So hence the focus on embodied carbon that I'm going to illustrate with a first just conceptual case study. We're going to come back to this a little later. But this is an office building for a hospital that we did a few years ago outside of LA. It's a 100,000 square foot building. It's in LA, it's on the California grid, it's electrified. So a lot of those operational pieces were already kind of minimized through location and through design. They were able to minimize the amount of enclosed space, pull the circulation outside. You can do that in a very nice environment. like this. But conceptually, we're starting to get this idea of embodied in operations. And what I've drawn here is just kind of a conceptual plot of those initial embodied emissions shown in red happen over, very few years, but ramp up, and then over time, the operational emissions add up and add up and add up. But what we're doing by making buildings more efficient, as I mentioned, decarbonizing the grid, we're flattening that line. Maybe even sometimes we're talking about net zero operational buildings where that line it's not truly flat. It bounces up and down from time of year, but it nets out to be flat. But if you're not addressing the embodied emissions up front, you're still carrying them with you throughout the life of that building. So what we're looking at in design is a more holistic approach of carbon emissions, both from the operational and the embodied. So we get something conceptually like the shading here overlaid on the previous one, where we drop the upfront by a certain percent, and then we still have our efficient building. But what it is it's a net win, and we get that area under the curve that many people talk about is reduced. So now that we've conceptually talked about what is embodied carbon, understood why we need to address it, where it comes from, the question is, how do we measure it? And what's tricky about this is that we don't have a nice, clean meter or a couple meters like we do for operational energy. For decades, century, we've all had meters on our electrical panels at home, or gas meters, because we need, the utility needs to know how much energy they're supplying us so we can pay for it. That's kind of masked a lot more when we buy a product. But we can use a method of environmental accounting called life cycle assessment, which the EPA defines as the evaluation of the environmental effects with any activity. So it can be a building, or I was giving this presentation to our new hires, or a variation of this presentation to our new hires 2 days ago. And one of them said, I did an LCA on a taco to compare 2 different tacos. And so you can do it on a building, you can do it on concrete, you can do it on a consumer product. But looking at from initial gathering till all the residuals are returned. And what this means is, every time we do anything, we emit something to our atmosphere, we take something from the earth, and we have to understand that balance in accounting. Now, this is the first kind of, if you take away 1, 2, or 3 things from this presentation, one of the things I'm going to take a breath on, and I want everyone to understand, life cycle assessment is not life cycle costing. We've seen many times where LCA might make its way into some project requirements, and someone who isn't as familiar, and many people are not because we're all learning, think that it's life cycle costing, but it's not. It's similar. In both, you're looking at some functional equivalent over the life cycle, and when you get into components that wear out, you're looking at replacement and refurbishment schedules. But life cycle costing is looking at it in terms of dollars. Life cycle analysis is looking at it in terms of the environmental impacts, and is environmental accounting. So the next piece is, so we can do this process, where do we get the data? And someone needs to study that data, and there are a number of data sets that can drive these analyses. Some of those data sets are industry average or generic, and there's a whole nother set of LCA professionals who will go to a producer, will understand the material and energy flows, and will come out either with just the data for a process, or put it into something called an environmental product declaration that we're seeing. There's probably thousands of them being created every day now. And with the new either requirements or pending requirements that are being discussed, there's a lot of funding to help manufacturers of construction materials create these EPDs. And what these EPDs are is the reports. Right now, they usually come in, they're usually 5 to 10 pages long. They're the results of that study. They can either be on an industry average basis. So a trade organization like the American Institute of Steel Construction can make one for wide flange shapes that represents all their members across the US. or a single producer, as we're seeing here in the case of Martin Marietta, and a certain ready mix concrete that they made can produce that. So you can then have that. It follows an ISO standard. There's a set of rules called product category rules that dictate what should be measured, what shouldn't, the cutoffs, et cetera. So we have a more comparability and they are reviewed. But that data exists for a product. Much in the same way that we think about our food, and when we go to the grocery store, we've for a long time had standardization on nutritional facts. Whether or not people choose to make the right choices or read them, that's a different thing. But the EPD is like the top part of this label on a can of soup. It includes certain standardized measures. In the case of food, you're looking at fat, carbs, sodium, cholesterol. In the terms of EPDs, you're looking at climate change, ozone, acidification, these other environmental impacts. For some standard serving size in the case of food, or a defined functional unit, usually by mass or volume in the case of a construction material. So that way, as we're designing, we can understand what would be likely to be available. As we're procuring, we can actually ask specific people who might be supplying materials for their EPDs, and we can ask them either if they have, we're part of an industry average one, or if they have their own data. Most people, once they find out that their data is better, they get their own EPD made, but that can be used to look at buildings. Now, the other part, as we talk about life cycle assessments, where this really can become kind of an alphanumeric alphabet soup, is the building life cycle phases and stages that are looked at. So when an EPD, so those stages are labeled, A through D, and then with a number following it. And each one of those stages, as we have on this slide here, represents something. You are most commonly going to hear about A1 to A3. Sometimes people will say, oh, is A4 or A5 included? And then when we talk about a life cycle assessment or whole building LCA, all of those come into play. But A1 to A3 are the product stages. That is what is most often on an EPD, because that's what can be understood, the cradle to gate, coming out of the manufacturer's gate, because that's what they understand. They can create an EPD for that. You could create one if you knew the specifics of the construction process or stages, but oftentimes, the manufacturer, who usually has the largest chunk of the impact, the EPD will be A1 to A3. Now, when we look more holistically and we look at LCA, we're looking at what that means for the construction process, the use, refurbishment, and what happens at end of life. So if we think about this in two ways, there's two different types of comparisons that can be used to assess something like embodied carbon. One is simply the product stage, or the A1 to A3, or what we see on EPDs, and the other relates to the types of systems we're using and how much material we're using and how much we need to refurbish them and what happens at the end of life. So it's a much more complex analysis. And then there's also what's called module D that can be added that gets into things like recycling and also addressing for biomaterials, what's happening for biogenic carbon. So this is really important as we're talking about making comparisons and looking at procurement, to know what we are asking for and that we're making apples to apples and not apples to oranges comparisons. So the two pieces there are to understand what phases we're measuring and what impacts. And some of these other impacts are the consumption of non-renewable energy and measures of air and water pollution. So all of this data can go into tools that design teams use, and I've broken them into kind of two pieces. One are the whole building LCA tools, the one that just do multiple impacts through multiple phases, and others are tools such as the EC3 tool that I'll talk about in the procurement part, that are really supply chain accountability tools, but that are looking at EPD data and letting someone who, most often when you're buying the product, compare different functionally equivalent products. Now, for all of this measurement, all of this modeling, all this comparison. The other part to remember is the reason we're doing this is to get lower emissions. So we need real reductions. We don't just need some model that says we can get reductions that either are measured from an unrealistic baseline or that aren't achievable for some other reason. So that gets us into our designing for lower embodied carbon comparison with procuring for lower embodied carbon. And these aren't competing, these are complementary, because if we think about multiplying the benefits of both, 0.9 times 0.9 is 0.81. We want a reduction when we design, we want to get the right systems, and then we want to buy the right materials for them. And that's why, as a structural engineer, many times say, oh, Dirk, you're interested in embodied carbon. So what should we build out of, steel, concrete, or wood? And I hope that this presentation, if you're not already thinking this way, kind of breaks your mindset from that, because we don't have anything that's built, probably other than, any building that's built out of only one of those materials. We always build out of composites. We're putting, these materials together, even for the timber buildings. They've got metal in the screws. They've got a substantial amount, sometimes, of concrete in the foundations and the floor slabs. The other thing that we're seeing is images like this, or graphs that aren't wrong, but we need to understand what they mean when we talk about embodied carbon and functional equivalence. So this came out of a paper that said concrete is a low impact material. And some people might say, well, that's not what I'm hearing. But well, what do you mean when you're talking about this? In this case, they're talking about energy, embodied carbon per mass. But the truth is, different materials, you can do different things with the same mass of different materials. So we need to look at functional equivalence always. Similarly, there's this really cool, riff on the food pyramid, right? When we can have the carbon pyramid. This is for enclosure materials. And it is a good resource, but we need to, not just write off things at the top of the pyramid, because it's not just carbon per mass, it's what you do with that mass. And, insulations are going to have different masses in a building than steels and concretes. So consider functional equivalence and consider complete assemblies, not just materials, when designing. That's very important. So now we'll roll through a few case studies, stories of that really take you through our arc of addressing embodied carbon on the design side. The first one I'm going to touch on is a 30-story commercial building in downtown Houston. This is a spec office building. Skanska developed and built it. And when they started, the LEED version 4 and the life cycle assessment and carbon pieces of LEED were very new, and they said we want it to be platinum, which meant that we weren't leaving credits on the table. We needed to do everything, and it was during the beta test phase of this. So we led that process for this team. We were doing the structural and civil and other services as well. But the first thing we needed to do is we needed to understand what was causing the impact. So this is the Revit model stripped away, just to kind of show there's two pieces of this building. We've got on the left the superstructure, and then we took away all the superstructure to show, the foundation. And that's significant because in a place like Houston, that mat on the right is a half city block, 7.5 feet thick of concrete. So we started to understand where are impacts coming from, doing some basic modeling, that first 80-20 kind of rule modeling to understand what's driving this. And what we saw, and I drew a little red dashed box around embodied carbon or global warming, the blues are the structure, the reds are the enclosure. We saw that for most of this, it was coming from most of the impacts, more than half of the impact was coming from the structural frame. The balance was coming from the enclosure. Not across the board, but in terms of carbon, it was about 2/3, 1/3. Then we started to strategize and say, all right, if we're going to advise our client, we're going to be doing some modeling, and we've got to think about the real world as well. What of each of these different pieces could we model? Where do we have the data to make these changes within the tools we were using? This was a few years ago. And then can it be implemented? So I'm going to contrast a couple things, like the roof. We see a little red dot, and that's that's the size of the prize illustrated on this matrix. Lots of data for different roofing assemblies, and a reasonable ability to change it. but it just wasn't that impactful if we were trying to make reductions. Contrast that with the curtain wall. The renderings, the sketches, that building, while we were designing it, there was a way that building was going to look. So we couldn't come back and say it's going to be brick, or something like that, hypothetically. And also at that time, the tool didn't have a lot of granularity, so we didn't really feel good about, making those justifications for changes. So the sweet spot was the concrete mix design, because we had the ability to model it, made a lot of impact, and we had the ability to actually affect changes. So this is the quick kind of concrete 101 in carbon piece of understanding why concrete comes up so often in discussions of embodied carbon. So if we take a test cylinder, those of you who are engineers or worked in materials lab know them very well, but it's the way that we check compressive strength of concrete, usually like 6 inches by 12 inches. But if we cut that cylinder open, you'd see something like this. You'd see a lot of big rock, you'd see some smaller rock, and then you'd see the paste that kind of ties it all together and glues it together. If we abstracted that and looked at where it comes together by mass, you'd see that a lot of it's the rock and the sand, and then the binder over here on the right, cement's the gray, some of these supplemental materials, fly ash or slag is the white, the water's the blue. That's kind of about how it comes together by mass. But when we look at it by carbon, this is how it's made up. Overwhelming by the cement. And that's because to make the cement, we need to make this clinker, which is CaO chemically. Only equations in my presentation from the engineer that we're going to have today, but a little bit of cement chemistry. We take limestone, we cook it to get clinker. If you want to take limestone, which is calcium carbonate, CaCO3, to get clinker, you're going to cause CO2 when you cook it from the temperature, and you're going to chemically evolve it. So that is why we talk about cement, concrete, but really cement, and really the clinker being a big part of the carbon driver of concrete. So what we did, and this is where we start to get into the design, meeting procurement, writing specifications. The way we put together our requirements for concrete is in this matrix. It has a lot of different requirements, but we start to put these environmental requirements over where you see the yellow and green onto it, moving from saying, oh, just replace the cement, but maybe sometimes capping the amount of cement, really clinker, that can go into these different mixes, understanding by the demands and the other needs for the mixes. But now that more and more suppliers have EPDs, we can actually use the environmental metrics that they submit back, and we can set targets, and we can understand that. Now, all of this also requires good communication, knowledge of the market, and communication with the team. So this is kind of the conceptual org chart we had for the project at a very granular level. But we were down over on the left, structural engineer doing carbon work. Sometimes that can be passed up through a bunch of different processes, and the game of telephone can happen when it gets to the mix designer. What we did was, to Skanska's credit, able to break down the barriers and have direct discussions, which led to, this is kind of our end result for that project, looking at that Revit model in a different way, instead of just all gray for concrete, shaded based on the carbon intensity of the concrete for the different elements. And I want you to notice here, we've got some green on the left all the way up to some red. So those are different elements. The mat foundation was able to be much lower carbon. The floors and parking, we had requirements for durability and whatnot. They were, in between. The lightweight floors at the top were even higher. So it wasn't uniform. It was not one size fits all, but that's how we got to overall reductions. Different type of structure, but where design addressing embodied carbon works as well. The MLS stadium that was just built in Austin. I live in Austin, so it's fun to go to the games here. We were able to work on that, both from a multidisciplinary approach, but from a carbon approach as well to support its LEED rating. And what we looked at here was the concrete, of course, but if you look over on the right, over that end line seating, you see a deep truss. This is the first architectural rendering. This is the concept that they had. But as we moved through design, that was a lot of material. We came to a cable supported solution, and we were able to use a lot less material for that. We were able to demonstrate in that cable solution, which was unconventional, which kind of cost about the same because working with the cables required a bit more coordination, these different analyses that showed, and here we have 5 different scenarios for this, looking at which of all the different materials were contributing. The yellows are the concretes, the greens are the metals, the pinks and blues are the enclosure. We looked at that not only up front, kind of the 1 to 2, but then we monitored it as the mixes and different things were coming in. So in the end, we have the cable solution that you see here built, and those cables actually, came from Europe, and they are more per pound carbon intensive. But when you look at the transport emissions and then the reduction in other materials, it becomes a net win. So this is where we need to not just say, just use steel that's less than such an impact, but be looking at the systems as we're designing. Coming back to the building I started with, it has another kind of angle on this story. This is in Southern California, concrete building, seismic load, large lateral load resisting system, a lot of concrete. But what we found for this one was that, and you can tell that picture is not from Southern California, that British Columbia actually had an important role in this, because some of the concretes made in Southern California, if you use the local aggregates, they're lower quality and they can require more cement. Some of the producers import really high quality aggregate from British Columbia, barge it down the West Coast, a long transport distance, but based on the mode, transported in an efficient way. So what we saw here was comparing the baseline mix on the left to the mix that used the aggregate from the British Columbia barge. The yellow is kind of the cement impact in each one of these. The grays are the transport emissions. So we do see that you could say, well, yes, you tripled, maybe even a little bit more, the transit emissions of that. Absolutely, but the higher quality aggregate allowed a cement savings and a net win. So this is where in this process we need to be looking at, when I talk about those alphanumerics, not only cradle to gate, but also what's happening with transport. The same thing applies to enclosure, but what we need to be doing is, we're thinking about even more pieces, because enclosures are complex. We've got a lot of different materials layered together. We need the building to be energy efficient. We need the roof not to leak, absolutely, and we need them all to work together. So back to functional equivalence and not just materials. So what we found here is that it's really a hotspot analysis is the way to do it. So looking at this product, here we've got an example of a thin shell precast wall panel broken down into 5, basic assemblies, and looking at how they contribute not only by mass, but what's contributing to the global warming potential, or we could do this for any of the other impacts. But here we see that, the spray foam on the mass was a really small piece of the mass, but was about, almost 10% of the impact. So that gets into which spray foam is used, which system can accommodate different types of spray foam, be functionally equivalent. Concrete was a lot of the mass, give or take 50% of the impact. So that needs to be paid attention to as well. But mass is not necessarily proportional to global warming potential when we look at it in assemblies. And then when we're looking at enclosure and enclosure design, it's not only what material is being used, but how much of it is being used. How does that impact the overall performance? And how does that also impact things like the structure? Here's a study when we were doing for a university very early on, but 3 different ways the building might be conceived. And we were looking at the glazing assemblies, brick assemblies, terracotta. There were impacts to each one of those. And then sometimes when we were comparing some of these heavier walls, what we found was that they were actually then driving the structure for deflection requirements and weight requirements and seismic mass. So it all trickled together. And in our practice, we've really stuck on the old Drucker adage that if you can't or you won't measure it, you can't improve it. And that this measurement's really important through our practice and understanding that. So just kind of sharing a few of the things that we've been doing. One is creating dashboards to measure embodied carbon. In our case, we're using them off of Revit models or off of the data in the quantities, pulled at some regular interval, depending on what works for the project, and plotting it over time. So this is in a platform we're using as Power BI from Microsoft. But on the left, we've got a donut chart that's showing for any snapshot in time where the carbon's coming from for whatever system. Here we've got the primary structure. And in the right, we kind of track it over time to see where the what's happening. There's really 3 moves that you can see on that over time. One is about at the middle of that chart where we went from kind of tracking at industry average carbon numbers to looking at what we understood from this market. This is a healthcare building in Atlanta. What could be achieved? So our model then included the provisions that we were putting in our specifications in that matrix I showed earlier. And we had a drop, and then we just had movement as far as quantities and volumes changing in the design till we get over to the right where we've got an uptick, and an uptick really in that kind of light red down at the bottom, because what we found was for the specifics of this project, we were a little overly aggressive, and we had a discussion, and we had an RFI that came in when the mixes were there, but we were a bit of an increase, but still tracking and understanding what's actually going to be built. And then that's also been tracked through making sure that the mixes are those as delivered. And just another way to look at it would be to look at which assemblies are creating the embodied carbon. And we've had some success looking at, a building spatially and how it's distributed, and then illustrating kind of which color is the embodied carbon. So I share these as some ideas of what you could include and look for to understand this and bring some daylight to it. So that's kind of the design piece. And taking away the important part for the design is that we need to be thinking about systems, and then we're going to procure them based on, of course, specifications. And those specifications could be kind of environmentally performance-based, or it could be a case where, and sometimes we're seeing this, and I would hope that we're going to see this less, but where we're not thinking about it until procurement. But if you don't have that luxury and you are a contractor or someone who just buys materials, you can still make those benefits. Now, the best way, or one of the tools that we were part of the early stage development on and piloting is the EC3 tool. I think as most people know it, but the Embodied Carbon in Construction Calculator, a tool developed by Building Transparency, which is an interface that allows suppliers who have made their EPDs to put them into a common database that then anyone can query either through their defined graphical interface or through using ways to kind of an API, a programming interface to get back to the data and bring it into our models. But thousands, I think would say hundreds of thousands of EPDs now, and then understand through visualizations where your project might be and what procurement choices you could make. So this will show you EPDs down to the supplier, will show their numbers, and they also are incorporating a methodology to include uncertainty within that. That's under development, and those uncertainty factors, as we better understand what matters, are being refined, but a way to compare 2 different EPDs. It's a really easy tool. Here's a screenshot. I'd encourage everyone, you can go to Building Transparency after this, set up an account, go and play around with it, and you can look at EPDs and to understand what's available. There's the most for concrete, and it makes sense because it's a material that has a comparatively significant carbon impact for how much how we use it. It's on almost every project. And there's a lot of EPDs because it's highly regionally dependent, as well as, every ready-mix supplier probably has a book of, at least a few hundred mixes that they might supply. But you can put in different performance specifications, regional limitations, and see what the range is. Kind of an example of that you could do is, here's a search for 5,000 PSI, 5 KSI concrete in California, and it shows the range and the outliers for what you might get from different suppliers and EPDs. But what's important here, and I highlight the the locations here, you can search by California, but if you're not thinking about it, and certainly people, sometimes people have done this who don't understand concrete, like you need to be searching for a tighter radius, because while you can see here that, say, Central Concrete looks to be the lowest, you're not going to get that outside of the Bay Area, outside of the 90 or 120-minute limit that the engineer is going to have on the spec from when that is batched to when it's, placed. So the other piece is sometimes people will say, oh, well, I see two suppliers who are low. Well, those are both in the Bay Area. The two that are a little bit higher in LA, that gets to the regional geologies. So you need to be savvy when you're looking at the data. And then I'm going to wrap up with a procurement example of this on a project here in Austin that opened about a year ago. It's the headquarters building for a municipally owned energy utility. Austin Energy also has a green building program. So this was a project that was very important to have high sustainability goals. In that picture, you can see it's actually a two-sided solar array or for portions of it on the roof, produces a large amount of the power. But we were involved in the role of working with Embodied Carbon, performing whole building LCA, and helping them with one of the lead credits that relates to procurement of low carbon materials. And on this project, the EPDs that I mentioned, the project was able to collaborate and catalyze the Austin market to have Martin Marietta, the supplier who supplied this, mix-specific EPDs, the first project to have them for all of their mixes in Austin. Those EPDs are not limited to use on a project. Now they can be used by any project, and we're having more and more that are more and more suppliers who are supplying. And what I thought was really interesting about this, because we had a project where we had all of the EPDs with a global warming per mix. Last March and then revised in September, GSA came out with standards for low embodied carbon concrete, where they put out, based on different strengths, GWP limits, so we could compare how these mixes were comparing to the GSA limits. And I created a plot here where we see how the mixed GWP and a ratio to the GSA limit. And then just kind of the x-axis is the GWP of the mix, so how intense it is. And what you could look at this for what we got about 2 years ago when we had the EPDs to substantiate it, you might look at this and say, well, half the mixes are above and half the mixes are below those thresholds. That's absolutely true if we're only looking at it by mix, by mix, by mix. But the question of functional equivalence becomes, how much of it are we using and how much does it mean? And here we've taken those dots and we've rescaled them to be by volume that was on the project. So I point this out because sometimes if we're just looking at thou shall not use a mix less than whatever number, there might be a good reason for a small amount to use a more carbon intensive mix. Maybe something happens, maybe it's scheduled, maybe you've got to keep going, or maybe there's a really specialty piece, and then have most of your volume and your bang for the buck be the ones that meet it. So back to understanding what we're measuring, what impacts and what phases, very important. And I hope you're taking some of that away from today. So I'm just going to close with a couple of resources. Whitney mentioned one of the organizations I'm involved in and our firm has been involved in is the Carbon Leadership Forum from the University of Washington. They incubated both the EC3 tool, they helped with that, and they also have local chapters they call hubs, a community. There's a lot of initiatives, a great group to get engaged in if you're interested in more in embodied carbon, and they do have a local Washington, D.C. group as well. SE 2050, specific to structural engineers, but put forth by Structural Engineering Institute of ASCE, a group of structural engineers who are committed to measuring, managing, and advocating and reducing embodied carbon in their designs. A few of our stories in more detail were put together in our stewardship report from a couple of years ago, but fully focused on embodied carbon. And really, I just close you with this charge. Whatever you're working on, whatever project, ask the question, measure, where's the carbon? Get that sense of where the embodied carbon is. And now we've got time for some questions and some discussion. So thank you very much, Whitney. And I look forward to talking more. Thanks for the opportunity.
Hey, no, Dirk, that was great. Really appreciated it. I always like to see, especially large sports facilities and stadiums you're building. Very, very cool. So, by the way, if anybody has any questions, please feel free to enter them in the chat, and we'll get to them quickly. But I do have a couple of teasers to ask you first. So, we definitely have a diverse group of people on the call right now, but we have a good group of owners, who ultimately would set the project requirements, and what advice would you give the owners, who really want to achieve, lower embodied carbon projects?
Yeah, well, thanks. And that's one of the pieces that I think can be a little bit of a challenge, right now, because this is all moving so quickly, and sometimes there's a natural arc of how the procurement process happens. But the earlier and that is articulated, and that it's clearly articulated, is really important and can be a driver of success. I know that, depending on how you're procuring, you might be able to put stuff in at the end, but I think from the first solicitation, letting the whole team know that this is important, that it's going to be measured, and there's a number of emerging frameworks. Sometimes people say, I want 10% less. Now, that's fine, but make sure that you are also clear on 10% less than what. Because what we're seeing is, somebody says, I made a 90% reduction. I mean, when the number's that big, you kind of start to really ask if it passes the sniff test. But, looking at, what are you measuring from? Are you measuring from what you did on a last project? The more specificity that can be handled, can be put forth, is important. I would also say, once design starts, really getting everybody together. The other thing that I often see happen is teams wait too long. Sometimes somebody says, oh, we're going to get to it, we're going to get to it, we're going to get to it. And then there's that real hard temptation for people to say, oh, can we just kind of reverse engineer or move the goalposts? And that doesn't get us to what we need to do. So
okay,
thanks, Whitney.
All right, great. And we got a couple of questions coming in. I know we're going to run short on time. Is it Sunil? Sunil asked, what is the website that had which website has that program you mentioned?
Yeah. All right. So it is buildingtransparency.org, and I can drop that into the chat as well.
Okay. We have a couple other questions in here, and this is from Catherine Thomas. She had can you multitask, or you
Yeah, I'll try. We'll go for it.
Okay, well, go ahead and put it in there first before.
All right, yeah, it's in the chat. And I would say that's the one that I mentioned for the procurement tool, where you can get to the EPDs. I can also share. There's a few. There are also the websites of the Athena Institute and the software tool Tally, and EC in one click that I mentioned some of the LCA tools that can be used. But yeah.
Okay, this is a question from Catherine Thomas. She asks, this is a question that is outside the low carbon material discussions. Did your firm run into any permitting issues, or do you know of any that had to be overcome to complete a project? She's a business consultant that offers NEPA compliance. Any lessons learned or best practices that those across the sector or even outside that'd be valuable for our small business permitting staff?
Yeah, so all the examples that I talked about were in they were kind of constrained by needing to meet code, needing to meet the commercial realities, whatever they might be for the different projects. So part of kind of the optioneering, or how far can we stretch the rubber band, was to look at the different things. And there were some ideas that didn't happen for one reason or the other. But when you're looking at it in design, you can come up with these scenarios. And from that kind of early discussion of how we're going to address this, you can have a meeting where we can say, all right, here's what business as usual would be. And we usually try to do it based on, like, here's a couple projects that are regional that we did, that we benchmark against. Here's where we think you can stretch. And then here's some out there ideas that do we want to get creative and do we want to try to do this? So there are, usually it's not code, because the other part of functional equivalence is making sure that we're not compromising any element of performance. Sometimes it can be economics, sometimes it can also be procurement logistics.
Gotcha. Okay.
Good question. Thanks.
Absolutely. So we're gonna pause the questions for right now to wrap up the webinar. But if you have time to stay with us, please join us after the conclusion. We'll continue to answer any questions that you might have. I know I have a couple of extra questions for you, and I definitely appreciate Dirk's time here. But I definitely want to be able to wrap up the event and the webinar here. But I do want to thank everyone for participating in today's session. We really appreciated your time with us here today. It's been very informative and great takeaways for our posts. We had a lot of interesting interest from our participants, so thank you all again. But before we wrap up our program today, I'd like to share with you some of our upcoming events that we have planned. So please mark your calendar for our local post events, as well as our upcoming national events. So we are committed to bringing you more content and fun events throughout the rest of the year. The SAME national website is being refreshed, so look for our events on the post page with a slightly new address. Add classic to our website to get the full calendar of events. Our next First Friday session is April 7, called Mighty Micro Purchase Sole Source Superpower. Learn about micro purchasing can help both industry and government pay faster while in compliance with the FAR. So registration is open right now. As always, SAME members attend for free, and all registered participants earn 1 PDH. And are you interested in sharing your knowledge on current educational topics for the First Friday series with our members? We're accepting presentations starting in July this year. Visit our website so you can submit a topic today. The next opportunity is for 2023 STEM engineering and construction camps. These are camps that are held at different locations across the U.S. and are open to high school students who are interested in learning more about the AEC industry. The DC Post provides scholarships for the local camp to help up to 6 students attend each year. The application is due on March 15th. And as part of our society's goal to enrich the STEM pipeline, we've opened up our annual scholarship application for currently enrolled college students in the AEC studies. So last year we awarded $40,000 to 10 students. So please be sure to share this opportunity with college students. The application deadline has been extended to March 25th. So please don't delay and share this with college students who might be interested in this. And SAME National is hosting their members only CAP Week in Bethesda, March 27 to 29. There are special networking events and fellows luncheon, as well as brief from the DoD and civilian agencies to set up their upcoming initiatives and planning this year. So you won't want to miss this, as this is their first national conference of the year. I am also excited to share with you the upcoming 15th annual Small Business Conference that's going to be held at the Capitol Turnaround in DC's Navy Yard. You won't want to miss this, the event of the year, as we share federal, state, and local business opportunities for 2023, and you can definitely build a strong network that is focused around on small business. And registration is open for individuals, exhibitor booths, and sponsorship for this event. And SAME members do get discounts, so please visit our website for more details. And finally, we've started planning for our programming into the spring, so please be sure to visit our website to mark a calendar for upcoming events and programs, and looking at the national website for their events as well. Again, thank you all for attending this first Friday luncheon, and thank you, Dirk, for providing excellent content today. Look out for document delivery and a PDH certificate today, and the recording will be on the DC Post website later this month. have a great weekend, everyone. And Dirk will stay around for a couple more minutes. I know we have questions that are still people are curious, so we'll continue to answer those for a few more minutes for those who are able to hang around. So thank you all again. So Dirk, let me go back up to where was it? We had a question from, I think it's from Patience. She asked, when considering different options for projects, for example, enclosures, does that include a lot of collaboration with the architects, or is it something you all explore some and then propose options to the architecture team?
Yeah, yes. So it does require collaboration. So we might be doing, and there's a few different ways that might be happening. We also are sometimes we are the enclosure designer as well. So that scope could be kind of naturally shared with the architect. So in that case, it's pretty embedded in for the collaboration. But we're also at times looking at the carbon emissions of structure and enclosure. And the reason for that is that this core and shell scoping of carbon emissions is what LEED has bound it to. You don't have to stop there, but a lot of other groups have followed that. So when we're doing that with the architect, that usually involves discussions, looking at the first design, kind of another meeting, kickoff meeting, kind of this carbon kickoff meeting. In addition to maybe a sustainability meeting or integrating it as part of it is really important. So then we could talk to the designers and understand, what are you considering? What's the vision here? What's on the table? How far might we push? And then come back with, kind of some basic assessments of like, hey, here's a handful of options. Which ones do you like? And it's incorporating it into the design loop as really another design metric. I think personally, the way that it's going to be most effective going forward, right now there'll always be some people or some groups, people within our design practice who have a greater depth of knowledge on any topic, but on carbon, we're kind of talking about today. I think that as everyone becomes conversant and knows about the carbon implications of what they're designing, we'll get to a point where it becomes kind of a natural process, just like people might say, oh, well, that would be really expensive for this project. It might not fit. We're going to understand like, oh, that's a really high carbon choice, or we need to do these things, and then go to someone who's the expert who says, here's what I want to do, but here's where I'm hesitant. How can you help me? So it's definitely kind of a collaborative, tightening design iterative loop as we find a solution. So good question.
Yeah, that is great. Let's see. Tad Davis mentioned great presentation. Do you all get into cataloging into scope 1, 2, and/or 3 emissions for certain clients?
So a good question. We do. We have done carbon studies for different different clients in different ways. I think so. Scope 1, 2, and 3. It's another way to think about the different types of emissions, different frameworks. So I think, Tad, that might be a good thing. We could follow up on exactly what which I would say the answer to that kind of depends on which framework. But we are doing studies for some different types of clients on their emissions related to their products and whatnot, their operations.
Okay, great. And then I think that's all the questions that I see in the chat. If anybody else has a question, feel free to unmute yourself and you can ask Dirk directly. Don't be shy. Okay. Nope. All right. Dirk, I think that will wrap it up for today. I appreciate you staying 5 minutes extra for this. So thank you again. Thank you everyone for attending. We look forward to seeing you next month on the first Friday, and please don't forget to sign up for the Small Business Conference. in April. It's going to be a great event, and we look forward to seeing you in a few weeks.
Well, thank you very much, Bree. Thanks, Whitney. Thanks for the opportunity to speak. It was fun, and have a great weekend, everybody.
All right, thank you.